See, a very, very tricky series problem. This, even a lot of good students will find this very hard, because if you go the wrong route, you might be stuck for minutes and you'll be wasting time. So let us see how to approach such series problem in general. This is a good trick to learn, and identifying this pattern will save you a lot of time. So sum the series summation r log r plus 1 by r. The sum of this is. So the four options pretty much are not giving you much of a hint. They are very complex, right? So let us see how to approach this. So the answer is C, but let us see how to get to that. Okay, so we have this and we want to sum it up. So now we know that log of a by b is log a minus log b. So let us apply that. This is obvious. We are going to apply this. Fine. So we end up here. Now if you sum it, and here is where if you sum it, you might do, you know what, n log n plus 1 minus n minus 1 plus n minus 1 log n, so on. And then you'll have minus n log n. So you could go that route, and you will you could expand the whole thing out, and you'll see some terms are cancelling, and then you might end up with minus of log 1 plus log 2 plus log n, and so you could then that becomes 1 times 2 times n, and that becomes log n factorial. So that is a possibility. So you have to be careful in that those terms are really getting cancelled, because when you sum it up, you will have n log n plus 1, n minus 1 log n, then you have to expand that. So which means that becomes plus n log n minus 1 log n, and then next time it is n minus 2 log n minus 1. So now it is n times log n minus 1, and so it gets very messy. So you can do it, but it gets very messy. Here is a cool trick, and this is a cool trick. The cool trick is that in summations, you make two terms that you want to sum look the same, but they're off by one factor. So why do we do that? Because when you do that, then the first term of one will be the second term of the second series, but it will have a negative, and hence they will start cancelling. So this is a cool trick here. So what we did was we took r log r plus 1 and we made it as r plus 1 log r plus 1. See that we make it as some term and log of the same term, because we have r log r. So when you had expanded the previous step 3, you would have got r log r plus 1 minus r log r. So you always have to look for patterns where, hey, I have minus r log r. If I get r plus 1 log r plus 1, then I would be cancelling out every term. And this is a very important observation. Keep that in mind, that when you have a negative term, can I get a positive term in summations which will look very similar but off by 1. So basically in this case we said r plus 1 log r plus 1 minus r log r. Then obviously to compensate for the additional log r plus 1 we added, we are subtracting that minus log r plus 1. So now the problem becomes very simple, because now you're going to just sum it up, and when you sum it up, as I said, you just expand each of the first two series. They will start cancelling, except for the first and the last terms. Everything else will start cancelling. So you will start seeing that. So when just expand those two, so you'll see that when you apply r equal to 1, you'll get 2 log 2 here minus 1 log 1. So that stays. But then the next time r equal to 2, you'll get 3 log 3 here, but minus 2 log 2. So the plus 2 log 2 and minus 2 log 2 get cancelled, and so on till you reach n, where you end up with n plus n log n plus n minus n log n, but the minus n log n would get cancelled. So you'll end up with n plus n log n plus n log n plus 1 from the first term, from r plus 1 log r plus 1 summation, and you'll end up with minus 1 log 1 from the second sum. The rest will get cancelled. And then the third thing is very simple. Summation of log r plus 1 is basically 1 to n is log n plus 1, minus of the whole thing, but log n plus 1 plus log n minus 1, and so on, which is log a plus log b is log ab. So we just multiply it and you'll end up with log n plus 1 factorial. So from here we know log 1 is, so we know that log 1 is 0. So we take care of that. Now log n plus 1 times log n plus 1 is, a log b is log of b power a. So log of n plus 1 power n plus 1 minus n plus 1 factorial. Now log a minus log b is log a by b. So log n plus 1 power n plus 1 by n plus 1 factorial. We cancel the n plus 1. So we end up with log n plus 1 power n by n factorial. Now we expand it again by log. So you'll end up with log n plus 1 power n minus log n factorial. And then we expand it again, n log n plus 1 minus log n factorial. So this is a difficult problem. This is where we have to save time in the rest of the simpler problems and use it for this problem. But here also in step 2, if you had used the cooler technique, you could have done it a little bit faster.